Hello, welcome to today's science show on density. So our topic for today is going to be on density. We're going to be looking at different ways that we can present density to children that makes it more relatable for them. Yes, so what is density? Can you tell me what density is? So in science, they'll say density is the mass of an object in relation to its volume. So every form of matter has its mass. So for instance, this cup, you can get the mass of this cup, like, oh, this cup has the mass is 500 grams, the mass is 1 kilogram. Okay, we could also get the mass of the egg to be probably 20 grams or 50 grams. So what determines mass and what is mass? Mass is the amount of matter that is stuffed into something, into an object. And then the volume is the amount of space that it is occupying, right? So yes, now, generally, solid materials are usually they have more mass than liquids and gases. And that is because their particles are tightly packed together. So you can see this egg, the particles are tightly packed together within the shell of the egg. Same as this cup, the particles are tightly packed together to form the cup. So it has more mass than water that is loosely packed. You can see that the particles in water, they are not packed together. So they are loose. And as such, water has lower mass. Now, in relation to their volume as well, solid materials have higher density than liquid materials. And that is all boiling down to the fact that the particles in solid are tightly packed, while the particles in liquid as well as gases are loosely and dispersed. And so how does that relate to what we're going to be learning today? Okay, I wanted to stay tuned with me till the end. We're not going to take so much of your time. So for young children, you want to teach them density. You want to introduce you to them by following scientific method, or you want to follow the 5E method. So today, let's use the 5E method. This is a model of science instruction in teaching sciences. So it consists of 5 words that starts from letter E. So we'll be looking at the engagement phase as our starting point. How do you present the lesson? How do you engage the lesson with children? So I'm going to be presenting it to you the way you want to present it to your children. So, you want to tell your children either a story, or you want your child to watch a movie or like a show on the computer, or you want your child to look at a trick that you must have done prior to calling her into the room. So, it's more like I've done a trick here, and I call my children that, oh, you guys should come around. What do you think is happening here? Can you see it? You can tell me what is the secret behind this, my trick? So, you can either, don't forget, come up with a storyline to get them actively talking with you. You could also show them a movie, a science show as an intro. So today, for our story, I'm going to be telling my children that, oh, there are ways that we can know if an egg is bad or if an egg is good. So you can see this egg. Can you tell me if it is bad or if it is good? Then they'll be like, Mommy, how do we know now? Yeah, you can know by what we call flotation tests, okay? So when you dip an egg in water, if it goes down into water, we call that sinking. So if it sinks into water, it means the egg is a good one, right? Now, but if it floats, that means the egg is bad, or the egg is going stale, and it's not advisable to eat such an egg. So now let's go back to our story. There are 2 market women, and the 2 of them are selling eggs, but only one sells a lot. A lot of people are always going to Mommy B's shop, and then Mommy B is always selling, like she comes to the market with a lot of crates of egg, and she finished selling everything. But Mommy A does not even sell up to half a crate. Then Mommy A was sad. What could be happening? Then instead of her thinking of, probably let me look at other marketing strategies to make people buy from me, she started thinking of, what am I going to do to make sure that people stop buying from this Mommy B? So she put up a stage and she was like, everybody, stop buying from Mommy B. Oh, her eggs are bad. And they were like, it's a lie. Her eggs are good. They said, okay, let's test it out now. Do you know that a good egg will sink in water, isn't it? People say yes. Okay, now bring her egg. Let me put it in water for you. Then she now started keeping it in water, and the egg were floating on the water. And people were like, are you for real? So she's selling rotten eggs. And Mommy A is like, no, my eggs are good. Okay, do you want to test it? Okay, no problem. Even though I'm going to lose the money, let's break my egg. And she starts to crack it open. Boom, boom. And they can see that, wow, the egg are still good now. What's now happening? Why is it floating in Mommy B's water? Why is it floating in her water? That's because she has done a trick. So she has done a trick to divert people's attention so they can buy from her. So you want to ask your child, what do you think she must have done? Then they start to think, and you tell them, yeah, so that will lead us to today's experiment on density. Mommy B is it Mommy B or Mommy A we are using? Who is not selling as such? Okay, so Mommy B that is not selling so well decided to add to the density of that water. She decided to add to the mass of the water, which would in turn add to the density of the water. And you don't want your children to start looking like, what is Mommy saying? So you start hands-on activity. Yeah. So I have my experiment partner, but then my experiment partner is on break because I want our class to be organized. So I'm going to say, let's start with measuring our water. When you carry out science activity, you take note of measurements, okay? So the cup I have here is 125 mils, and that is half of a cup. So for me to get 1 cup, I'm going to take 2 of these, and that will give me 1 cup of water. So I'm going to be putting 1 cup of water here. So because I want to have my water as being constant as well as my egg, I'm only going to be changing one of the variables, and which is going to be something. We're coming back to that. So I kept 1 cup of water here, 1 cup of water here. Don't forget I said this cup here with me is 125 mils. So if you do not have measuring cups and measuring spoon, just take note of the cup that you have used in your house. Okay, take note of that particular cup, because in our subsequent lessons, we are going to be recording. We'll be making use of our pen and paper and ruler to record, okay? So I've measured out my water. Then you ask the child to keep the egg in water. So let's start. Let's see what happens. Wow. So you can see that the egg sinks downwards. So try it in the 2nd cup of water. Awesome. So the eggs are sinking in water, and this is to tell us that they are fresh eggs. So you are already exploring with your child. So that's another E. So you are exploring with the child now. The child is the one putting the eggs carefully so it does not break. So the child is putting the eggs there. You now tell the child, the reason why the egg is sinking in is because of what we call density. Basically, when something is heavy or has an higher density, it tends to be heavier. And because I mentioned earlier that solid materials are tightly packed, the molecules in solid materials, they are tightly packed. So look at this plate. They have made it to be tight together. It's only when you break it that it separates. But look at water. Water is not joined together, like it's not like they packed it together. So water liquids are loosely packed. Air, gases, they are dispersed in our environment. So they are very light. So solids, because they are tightly packed, they are denser, so they appear to be heavier, right? Now, an object that is heavier can easily carry an object that is lighter, like water. So if I'm here, for instance, and I have a child of 2 years old with me, because I'm more dense than the child, I can lift the child on my shoulders. I can carry up the child on my shoulders. So the denser person is carrying the load, the less dense person, right? So yes, in this situation here, this egg is denser because it's solid, the molecules are tightly packed, they are joined together. And so it is heavier than water. So here we can say, in our children's terminology, you can say the egg is carrying the water, right? The egg is carrying the water. So the water is on top and the egg is below. Okay. So back to our story. Remember I told you that the second seller that wasn't selling too much, she already like carried out a trick to fool people. So what did she do? She added something to water. So there's a way you can make this water to become heavier than egg. So can you guess? Let's use salt. So yeah, salt, when you add salt to water, you are increasing the mass of that water. You know, the mass, there is salt here. If I measure the mass of this salt, it can be, let's say, 500 grams, right? Once I start to take out from the salt to my other plates, once I start taking out from this salt to my other plates, I'm reducing the quantity. Once I remeasure it, the weight, the mass would definitely have reduced straight to like 400. Now, once I'm adding to it, I'm increasing the mass now, right? So you see people that when you can either increase the mass by adding to it, or you can reduce the mass of an object by reducing from it. So I'm going to be adding salt to this water. So you see why she added salt. So now I'm going to be using measuring spoon. If you do not have measuring spoon in your house, I will encourage you to buy them. They are quite cheap. They are about 700 naira, about $2. So yes, they are quite cheap. You can always get a set, and they are usually packed together. You can buy this from baking stores. So it has about 5 cups, about 5 spoons as well, in different calibrations. I'm back. So yes, you could. So yeah, okay, we were talking about the measuring spoon, right? Now I'm going to be taking note of how many spoons of salt I'm going to add to this cup of water. So this is something that if you want to use the trick as your own engagement for your child, you would have done this prior to now. So I would say this is a 5 ml spoon, 1 tablespoon, 1 teaspoon, sorry. So I'll add 1, 2, 3, 4, 5, 6, 7, 8. What's happening? You can see that the egg has floated to the top of the cup, right? The egg has floated to the top of the cup. Okay, so now you take note of the countings, because these are the things you'll be recording with your child. So you know how many spoons did we count to 1 cup of water. So you can see now that the egg is floating. Why is this egg floating? The egg is floating because the salt has added to the mass of the water. And as such, it automatically makes the water denser, or let me say heavier than egg. Okay, so that's why the salt water now is carrying the egg up, is lifting the egg up. And you know, when anything is staying on top water, we say it is floating on water. So let me go back to that trick for you mamas and daddies in the house. I'm going to take out my egg now. I'll keep it in a second. Then I'll pour this water here in a second cup. Now what you can see, the residual salt beneath, I'll take it away so that it doesn't remain in the cup again. Yes, so I have a neat cup here with me. Then I'll transfer the water back. Now you can see that the salt is no longer in this water. I could even dilute it now to make it look pure, so that my children do not get to see any difference. You know, some children will be very smart. They'll be like, Mommy, this one looks a bit cloudy than this. So I would try to dilute it so it doesn't look so cloudy. You know, okay. Is it looking almost the same? I could even add a bit of salt water here just to make this one look a bit, have that same cloudy nature of this. But then I'm adding the residual salt water, so it would not, it won't add it won't add so much weight to the egg, so it will still remain the same. You know, when we were adding the salt also, it was coming up gradually. So now let's put this inside. So it's still floating even after I've taken the salt away from it. Okay, let me check. I've diluted it too much. Let me add salt again. Okay, so I've diluted it so much. So let me leave it. Let me add again so it comes up a bit. Okay. Okay, so now you can see here we have the egg is floating here and it's sinking here. So we want to tell our children that what the other seller was trying to do, she already kept salt in water. She tried to mask it up, or maybe she's not even giving them a second option of a cleaner water. And people were like, oh, this water is still looking pure now. Okay, it's still looking pure. And she has taken away the salt from it. So, you know, she started like, everybody start feeling the person is selling a bad egg just because she has kept it in salty water. So you want to tell your children that in a rotten egg, the yolk, the egg yolk that is inside, and all of the particles inside that make up the egg, they start to decompose after a while. Like, so after it gets stale, if it's getting long on your shelf, it starts to like decompose. And when it decomposes, it gives us gas, like rotten gas. We start smelling that, oh, this egg is already spoiled. Now, the shell of our egg is quite porous. It allows air to move out. So once the gas starts to escape from the shell of the egg would be automatically reducing in mass, and in return it is reducing in density. So that makes it less dense than water. So if this egg were a bad egg, it would have lost gases. I hope you get what I'm saying. You know, I said the egg yolk, everything, the egg white, all of them, they will be decomposing because it's already getting too long, it's already spoiling. Now that decomposition will give us, we'll be giving off gas, and then the gas can escape from the shell of the egg You might not see it, right? You might not see because the shell is quite porous. So the gas is escaping, and as it is escaping, what's happening to the egg? The egg is reducing in mass, and in turn is reducing in density. So it would even be floating on this fresh water. Okay, so then you explain all of these to your children, and you need to like elaborate lessons to your child, and you need to extend lessons to your children. To extend the lessons, you want to extend it to real life application. How does this affect us in real life? Now, it affects us in real life in the sense that when you are swimming or you are beginning to learn to swim, you would use floaters when you want to swim, right? You use floaters. The floaters are packed with air molecules. They look like balloon. They are like they are balloon-like. They are filled with air. And that's because air is light. So automatically you become light once you are putting on the floater around you. So it doesn't allow you to sink into water. The floater protects children that are learning to swim, or even adults that are just learning to swim. It protects you from sinking into water because air, don't forget we say air is light. They have low density because their molecules are dispersed. They are not tight. They are not heavy. So yes, now it's because of that same air that has escaped from here that is also making this a bit, is also making the bad egg to seemingly float on water. Now let me try something else with this egg and let's see. Or let's use this one. Okay. I'm going to try to put it in water again. Remember that it sank the other time. So I'm going to put it in a bubble wrap. Now you do not need bubble wrap. If you have it, you can test it out. So bubble wrap is filled with air, right? There are air there. So I'm going to tie it. Let me use a bigger wrap. I'll fold it around bubble wrap, but that's putting air around the egg. Then I'm going to tie it up with a rope. So let me keep it in my fresh water. Before now, so I want it to be able to enter. Before now, it should have sunk into water, just like this. It's supposed to sink. But why is it not sinking? So now I've wrapped it with a bubble wrap. So it just stays on water, right? So it is not sinking into water. Even when you use a cup with a wider circumference, it will still stay on water. It will just sink. Okay, so that's because you have covered it with air. So it automatically makes this lighter. So you know, on the Red Sea, on the people can float on it. Even in oceans, people float on oceans. So a lot of time when people have accidents in beaches, the ocean would return their body because the body would not sink into water. That's because of the high level of salt that is in the water, which is not allowing the body to sink in water, right? Because of the high level of salt. So here in this our experiment, we can say that our egg will float in salt water, right? The egg floats in salt water because salt water is heavier than the egg, but the egg would sink in fresh water because the egg is denser than the fresh water. I hope you understand today's experiment. If you have questions, you can always ask me and I would be glad to reply. Okay, so see you some other time. Bye.